Hello everyone, I'm Pierre Pouchin from Clermont, where I work as a research engineer at the Institute of Genetics Reproduction and Development. Here we have a confocal imaging facility called CLIC, where we do a lot of images, and thus we developed, in collaboration with MICA, Microscopie Imagerie Côte d'Azur, two ImageJ plugins to easily interact with images on OMERO. So first, what is OMERO? As a reminder, briefly, OMERO is a software made to store and organize macroscopy images on a server using clients, either web or standalone, connected through the network to the server, either locally or across the internet. The question we had was, when you use Fiji to segment and analyze your images, how can you easily work with everything that is stored on OMERO? How do you automatically push your results on the server? To do this, as I said earlier, we developed with Frédéric Beau from MICA a set of plugins making things easier. The first one, to easily let users choose through graphical interface what they want to process, which script should be run, and where to store the results. The second plugin actually adds macro extensions to interact directly with OMERO from ImageJ macros. Both plugins can be found on GitHub here and there, and each of them has a release page with instructions on how to install the plugin. So first you need to install the OMERO Insight plugin for Fiji, which you cannot download from the download page here. Once it's done, you just need to take that and put it into your plugins folder inside Fiji. Then the second step is to download the library we made that is used by both plugins. So once again, you download the jar and you put it in Fiji. And finally, you download the OMERO macro extensions jar file and put it in the plugins folder. For the other plugin, you follow the same thing. You go to the release page, follow the instructions, except you already installed the OMERO Insight plugin. You already installed the simple OMERO client library, so you only need to download the jar file for the OMERO batch plugin. So we download the jar and we put it into the plugins folder. Once it is done, we can see in Fiji that we have a new entry, OMERO, here, with the standard menu items from the OMERO Insight plugin, but we also have OMERO extensions and batch process. Both of them correspond to the new plugins we just installed. Now, before going further and seeing how to use the plugins, we need to put data on the server. So I set up a local server on my computer. So if you need to use, you should put the appropriate server URL and connect to OMERO. I've prepared a few images for our use cases. So we are going to put these into a new project, which we are going to call process, for example, and we're going to import that into OMERO. Once it is done, we will be able to have a look at what can be done with the plugins. So while it's downloading and importing the data, I will show you the first plugin. So batch process can be started from this menu. So here you can handle the connection to OMERO. Here you can specify where the data should come from, either local folders or OMERO. Here we'll see later how to choose the input. This is to select the macros that should be run and what results are expected to be returned. And there you can specify where the results should be stored either on OMERO or locally or both. So to start, I'm going to connect to OMERO. Here we see in the input that we now can choose which group we want to browse. So for now, here we only have one group. Then you can filter the data to only show project and dataset from a specific user. So either user 2 or user, which is us. So I'm going to select a user, and now you can select which project and which dataset you want to process. So I'm going to choose dataset 2D, and first we are going to see what could be expected. So we're going to start with a small example with a 2D segmentation. So the 2D dataset contains images like this one, so the 2D nuclei. And one thing we could want to do is to label each nuclei with a different value. So mostly we are going to do a Gaussian blur, then threshold it, and run analyze particles to generate the count masks and get the labels. So this is what will be returned when we run this on one image. Now we are going to run this macro, 2D segmentation for labeling, on the 2D dataset. So each image from this dataset will be processed. The macro will return new images. We will have label images. So I will put underscore labels, or not in this case, no, I will put no suffix at all. And we will store the results on OMERO in a new dataset that we will call 2D labels. So that's it. We can preview the dataset to see if it matches what we are expecting. And now I'm going to click start, and the process should run. So the task is completed. If we go to the web client, we will see that now we have a new dataset here with the segmentation. So it's a grayscale, so we don't see properly. But if we adjust the rendering, we can see that we have the proper labels on the image. So that's for our first example. Now you may prefer to do something else when you segment 2D images. You may want, for example, to store ROIs and not labels. So we can see another macro that will do that. It's mostly the same, except we don't output the count masks, but we add the ROIs to the ROI manager in Fiji. So if we run this macro there, on this image, we get the ROIs for all the nuclei that were detected. So now we are going to run that on our 2D images here. So we choose the macro. Now we need to specify that this one will not return new images. However, it will return ROIs. So I'll choose ROIs. And we want to save the results on OMERO 2. Now I click start. And both images were processed. So now if I go back to here, I go to these images, and we can see here that we now have 59 ROIs on this image. So the process occurred properly. Now you may want to do the same thing with 3D images. Well, by the way, I will delete some images to reduce the number of images. So we will process this with a similar segmentation. So first to produce labels, so 3D images look like this one. So we have nuclei, but this time they are in 3D. What we may want to do is a 3D segmentation to produce labels. So if I run this, which will put once again a Gaussian blur and then a thresholding, and then use the 3D object counter and produce labels, if I run that, what we get is the following result here. We have the label. So we can do the same thing even in 3D. So we put 3D segmentation labels, which will output new images, and we'll store that in 3D labels. This time I will put a suffix labels, and I should not forget to select the correct dataset. So now we start. Once it's done, we can check on OMERO if everything worked correctly. So as we can see here, we do have label images in 3D. So it worked. Considering the time it took, I will reduce once more the size of the dataset. So now the question is, if you want to do the same thing, but instead of storing 3D labels, you want to store 3D ROIs, how do you do that, considering ImageJ doesn't have 3D ROIs natively? One thing is that the plugin can convert a list of 2D shapes in ImageJ to a 3D ROI in OMERO. We're going to see that now. So I will open a 3D image and a 3D segmentation script. So it's mostly the same as what we just saw before. So Gaussian blur, thresholding, 3D object counter, and labels, except this time we also have a function to convert labels to 3D, 4D ROIs. So how does it work? We take the labels, and for each label, we will go inside each time frame and each slice and convert the label to an ROI, except we put a property on the 2D ROI. This property should be the number corresponding to the number of the 3D object. It's an index. And here I'm also setting the group, but it's just for coloring purposes. So this is the important thing, is it's when you do 3D ROIs, this plugin expects 3D objects to share the same property here with the same index. So for example, if I process this image, oh yes, this script has script parameters. We'll see that later. So it's doing the processing. So here we see that the arrays were computed. we have a green here and a blue up there. So if we go to properties, we can see that we have ROI 3. So this one is green and this one is in the same 3D object and it shares the same ROI value. Conversely, if we go to the blue one, the first one, if we go to properties, we see that this ROI is number 1. So now we can try to do the processing on OMERO with the batch plugin. Once again, it won't return new images but ROIs, and this time it's a little bit different. There is this button that I haven't talked about before. As you saw, this macro has script arguments. So when it's the case, you can set the arguments that will be used by the processing for all images. So I'm going to put 3 and 1 here and click OK. And now all images will be processed with these parameters. So now if I click Start, OK. So the processing ran perfectly. So now if I go back to OMERO, I can go back to the original image, and here we see that we have 3D ROI on OMERO. So the first one here and the third one there. So green and blue. So now we've seen how to import new images and how to import ROIs onto images. So I'm going to show you how to import results table. So let's say you have done your image processing and now you want to quantify, analyze the segmentation. We can go to the analysis script. So we're going to start in 2D because it will be faster first and easier. So what does this script that I just selected do? So I will go back to one image, so this one, and I will first run the 2D segmentation with ROIs. So if I do that, I get my ROIs. I can reopen the image. So now we have that. And what does the other script for analysis do? If I run that, it's only well, measure mostly. So we will only measure everything in the using the ROI manager. So if I do that, yes, if I do that, I get the results for all the ROIs. So now, how could we import this into OMERO? So to do that, I'm going to select the 2D dataset. I'm going to say that this returns a results table that should be stored in the project here. And also, I need to specify that I want to load the ROIs that we computed beforehand using the previous script. So you need to check this. If I click Start, the images will be loaded. Oh. Okay, I will restart ImageJ. And I'm going to close OMERO Insight, by the way. If we reconnect, we can select once again 2D. We want to load the ROIs and do the 2D measurements. We store the results table in the project process. If I click start this time, everything works perfectly. Okay, so everything ran as expected the second time. So if I go to this image, I can see here that I have a table and an attachment here. So I can see the Excel file. So these are the results that were computed. And if I go to process, I can see here the table, so the CSV and the table here that was saved. So as we can see, the image and the ROI are linked to the results. How so? The image will always be linked, but the ROI requires a specific condition. So the condition is essentially that the ROI name needs to be included in the label here. So if it is the case, the plugin will automatically match the ROI that was computed in ImageJ and link it to the ROI that was imported inside OMERO. Here. So the question now is, can we do the same thing in 3D? So we can go to 3D and we will use a slightly different script. So this script is a little bit more complicated, but we're going to do the measurements. Except as we are working in 3D, we need to aggregate the data and compute a mean value for each nucleus. So here, what this macro is doing is essentially taking the intensity and computing the mean value across the different planes. So if I reopen a 3D image and reopen a 3D ROI segmentation, if I do the 3D segmentation here, I get the 3D ROIs here. I will reopen the image with the original intensity. So here we have that. So now if I go to the 3D measure and I run that, here I have the ROI number, which is computed because the value is here I'm using the group, but we could do it with the ROI property directly. And then I'm putting the mean inside the other column. So what happens if we run this macro on these images? So let's see. So everything worked for now. So we're going to go to the 3D image. And as we can see here, there are results. And if I go to the process, I can see here the 3D results. So as you can see here, we have the image ID and the ROI ID and the mean values. So once again, how are the ROIs, the region of interest, linked to their IDs in OMERO? Well, it's because the the results table in ImageJ contained a column named ROI, which contained the local index of the region of interest, and the plugin matched it to the OMERO ID. So how can you use that? This can be used using Wilmore parallel cost filter or the standard OMERO parallel, but mostly if you try to use the OMERO parallel, so the new one in this case, you can load the table, and here you can see the results, so the mean intensity for each ROI. So if you click on the line here, you will get the matching region of interest, and you can browse through the slices. So that's what's interesting when you link the local shape in ImageJ with the result and import it into OMERO. It's that you can see that here. So that's what you can use that for. If you notice something weird and the process didn't give you the expected results, and you want to rerun the process with different parameters, for example, the ROIs will be kept unless you click the clear ROIs each time here, which will remove the previous ROIs from the image, and before importing the new ones. So we can see that with the 2D, for example. If we do that and go to 2D segmentation, if I check this and click start, we can see that the arrays were deleted. So if we go back to the 2D images, because it's faster, we see that we only have still only 59 arrays. The number was not doubled. So now I'm going to show you that whatever we did on OMERO can be done also locally. So you can choose to process local files, either recursively or not recursively. So I'm going to open images from the 2D folder, and I'm going to run the 2D segmentation with labels, and this will return new images. Now we can store the results either on OMERO and import the results, or we can store the results locally. So once again, put that here. I will put the same to the output. Oh, yeah, of course. I first need to create a new folder to the output. So I'm going to start that, and now we have in the folder that we just created, we have the results. The same thing can be done with ROIs. So if I do that, oh, yes, if I do that, here we have the ROI files. So if I open a 2D image and open the ROIs, here we have the file corresponding to the image. So you can do the same thing in 3D. You can do the same thing with results table. And to do that, I'm going to load images and ROIs from OMERO, as you don't have to load local images to save locally. Conversely, you can load files from the computer and save the results on OMERO or on both. So now I'm going to choose the 2D dataset. We need to load the ROIs and select the analysis macro, this macro. We need to save the results table and click start. The results were saved as CSV files in the output folder as expected, so everything worked. Now, I loaded the images from the server for two reasons. One, to show that it was possible, and two, because this script requires ROIs to compute the results. And usually, ROIs are computed beforehand with this other script. But currently, there is one limitation that we can't load ROIs from local images. That's one limitation. Another limitation is that on OMERO you can only process projects and dataset at a time. You cannot choose screens and wells or plates. But maybe in the future such a possibility could arise. Another limitation that you have is that you cannot change the organization of the data on the fly. So, for example, if you want to tag images depending on the results of segmentation or measurement, this plugin doesn't allow you to do that for now. Maybe one day, but for now, you can only choose an input and put that wherever you want, but you cannot change how the input data is organized. So that's one limitation. However, that's something that the second plugin may help you with. So I'm now going to show you the other plugin. So you may want to click on this, but as I said, this plugin is made to add macro extensions. So it only works from macro scripts. So clicking on that will only tell you that it should be used within a macro, but it will output something to help you with the possible commands, so the functions that are available with the extensions. So now we can maybe check. So one thing is, as I said, you may want to tag images, for example, depending on the mean value of the mean value. So as specified here in the help, the first command you need to put is run OMERO extensions. Then the command you need to use is connect to OMERO. So here I'm going to take the parameters for the connection from the script parameters. And then I'm going to create a tag that will be called hi. And then I will open the images from the dataset specified here, 2, which should be this one. And I will open the image and check if the mean value is greater than 450. If it's the case, I will link the tag to the image. So, and at the end, you should not forget to disconnect. So what will happen if I click run? I need to input my credentials. and then everything is done. So the batch mode hid the images that were open. So if I go back here and refresh, I can see that if I filter by tag and want to remove to only select those with high, I have one image only, the image 2. Image 1 was not tagged, only image 2 was. So it's a pretty silly example, but it's just to illustrate that macro extensions allow you to interact with the server and reorganize the data while you're processing it. So that was the first example. Another thing you can do is just to list the projects that are available to the current users and make a dialog window to choose from. So if I do that, I need to input my credentials, and then once I'm connected through connect to OMERO, the macro will list the projects, retrieve the IDs, and then for each ID it will retrieve the name and create arrays to create the dialog and shows the options. So if I do that, I can see here other project and process. So as you can see here, I don't have other project, I only have process, because other project is something that belongs to another user here in this group that is read annotate. So here. So that's one thing you can do, is listing the object. So you can list projects, datasets, images, or even wells or plates, and you can display the names accordingly. Finally, with macro extensions, you can mostly do the same thing as what we did just before, meaning you can choose a macro file and connect with the OMERO extensions, and then select a dataset, list the images inside this dataset, and open each image sequentially and run the macro that was selected here and save the ROIs in this case. So if I do run and connect, I will choose the 2D ROIs segmentation. And if I go back to this, we can see yes, it was the dataset number 1, so this one. So we can see that here I created the ROIs for these images, which belong to another user. So this essentially does the same thing, but it needs to be scripted, and if you need to save images, you need to do something. You need to change this to save the image and then import it. To import an image, you can use the corresponding function, which should be something listed here. So import image. So if we wanted to save labels, we would need to save locally the image and then use or even no, We could just save the current image to the dataset and specify the dataset where we should save the image. One last thing, the OMERO macro extensions and the OMERO batch plugin handle the OMERO connection independently. So using both together may cause trouble. It has not been tested. So I advise to use either the batch plugin or the macro extensions, but unless you know what you're doing, I don't think you should use macro extension inside the batch plugin. So that's one warning. In any case, as I said earlier, both these plugins are available on GitHub. So if you have problems or suggestions, you can create an issue or a pull request, or even contact us to discuss it. We will be happy to have feedback. And I hope these tools will be able to help you for your image processing. And I thank you for attending this workshop, and I hope to see you soon. Goodbye.